Hello students, let us continue with the other problems in this exercise. See this question. Limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. First let us check by substituting x equal to 2. And if you put x equal to 2, what happens? You just see here 3 into 2 square, x is equal to 2 square minus 2 minus 10 divided by again x square 2 square minus 4. Simplifying this, you will have 3 into 4 12 minus 2 minus 10 0 divided by 4 minus 4, that's equal to 0, that is 0 by 0, which is indeterminate form. Now to solve this question you have to simplify the given polynomial. And you just observe, when x equals to 2, both numerator and denominators are 0. That is why you can conclude that x minus 2 is a factor of both numerator and denominator. And this you can use for factorization of numerator and denominator. And as we know the factor, it is easy to factorize. Just see here how to factorize this, and you know the method of factorization, and moreover we know the factor also. You can factorize very easily. Limit extending to 2, first you write 3x square. Anyhow x minus 2 is a factor, that's why as it is 3x square you have to write minus 6x, because you can take 3x common, you will get x minus 2. And it is minus x is given in the equation, it is minus x, and we have written minus 6x, and then to get minus x we have to add plus 5x and minus 10 as it is, that is splitting the middle term. And you know the method of factorization, in same procedure we have applied, but we know the factor, that's why it is easy to factorize, that's all. And x square minus 4 can be written as x plus 2 into x minus 2. In numerator you can simplify further, you will get limit extending to 2, 3x is common, x minus 2 plus 5 is common, x minus 2. And now you can take x minus 2 common in the numerator, limit extending to 2, x minus 2, denominator as it is, into 3x plus 5. Now x minus 2 gets cancelled, and what will remain? 3x plus 5 divided by x plus 2. And at this level you put x equal to 2, what you will get, you just see here, 3 into 2 plus 5 divided by 2 plus 2. 3 into 2 is 6, 6 plus 5 is equal to 11 divided by 4, which is the limit of extending to 2, 3x square minus x minus 10 divided by x square minus 4. And if you observe the graph of the function, just see here, the graph of 3x square minus x minus 10 divided by x square minus 4 is like this, and it is not required for the exam. Just to understand I am giving this. Just here, as x approaches 2, and you can observe the value of f of x is approaching this point, that is 11 by 4. And here in the graph at x equal to 2, function is not defined, there is a break here, and this point is not there, but f of x is approaching 11 by 4 from both left side and right side. And you know that denominator is 0 even at other point, that is x equal to minus 2 also denominator is 0, right? And at x equal to minus 2, what happens, you see here, from the right side of minus 2 it is approaching minus infinity, and from the left side of minus 2 it is approaching plus infinity. And at this point limit does not exist here. At x equal to minus 2 limit does not exist, but whereas at x equal to 2 limit exists, even the function is not defined. At x equal to 2 the limit of the function exists, and this problem will give the clear picture of the limit of a function. Let us solve one more question of the same type. Limit extending to 3 x square minus 81 divided by 2x square minus 5x minus 3. First you put x equal to 3, what happens? That's equal to 3 to the power 4 minus 81 divided by 2 into 3 square minus 5 into 3 minus 3. Just put x equal to 3 in the expression. And simplifying, 3 to the power 4 is 81. 81 minus 81 is 0. And 3 square is 9. 9 to the 18. 18 minus 18 again. It's equal to 0. 0 by 0 form. It is an indeterminate form. And when x equal to 3, both numerator and denominator are 0. And we can observe that x minus 3 is a factor of both numerator and denominator. And this we will use for factorizing the numerator and denominator in the next step. And next step is just here, just you have to factorize this, and this is equal to limit extending to 3, x to the power 4 minus 81 can be written as x square whole square minus 9 square, that is x square minus 9 into x square plus 9. And denominator should be factorized. You know the factor x minus 3 is a factor. Here extending to 3 is there, no? X minus 3 is a factor. 2x square minus 6x. Immediately you can write minus 6x because 2x can be taken common and x minus 3 will get. And it is minus 5x is there. Therefore plus x minus 3. That is splitting the middle term. And now you can further simplify like this. Limit extending to 3, x plus 3 into x minus 3. X square minus 9 can be written as x plus 3 into x minus 3 into x square plus 9 divided by 2x can be taken common, x minus 3 plus x minus 3. And now you can take x minus 3 common in the denominator. And numerator is as it is, x plus 3 into x minus 3 into x square plus 9. And denominator is x minus 3 into 2x plus 1. And x minus 3 gets cancelled. Now you put x equal to 3 in this expression. You will have 3 plus 3 into 3 square plus 9 divided by 2 into 3 plus 1. That's equal to 108 divided by 7, which is the limit of this function. And just to understand better, let us take the graph of this function. The graph of the function x to the power 4 minus 81 divided by 2x square minus 5x minus 3 is like this. And as x approaches 3, see the point here, as x approaching 3, f of x is approaching the number 108 by 7. Now you take this problem, limit extending to 0, ax plus b divided by cx plus 1. Here instead of numbers, some constants notations are given, and just keep the notation as it is, that's all. And if you put x equal to 0, what happens? Just check it in the beginning. That is a into 0 plus b divided by c into 0 plus 1. And that's equal to b by 1. That's equal to b, and which is the limit of this function. Next problem is limit z tending to 1, z to the power 1 by 3 minus 1 divided by z to the power 1 by 6 minus 1. This is of the form x to the power n minus a power n divided by x minus a. It is possible to reduce to that form. And just put z equal to 1, you will get 0 by 0. You can clearly observe. That's why you divide both numerator and denominator by z minus 1. And if you divide both numerator and denominator by z minus 1, you will have limit z tending to 1, z to the power 1 by 3 minus 1 divided by z minus 1 whole divided by z to the power 1 by 6 minus 1 divided by z minus 1. And we can write like this, limit z tending to 1, z to the power 1 by 3 minus 1 divided by z minus 1 divided by limit z tending to 1, z to the power 1 by 6 minus 1 divided by z minus 1. And the numerator and denominator both are in the standard form, and just you have to apply the formula, that's all. Instead of x, z is there, and instead of a, 1 is there. And limit extending to a, x power n minus a power n divided by x minus a is n a power n minus 1. Here what is n? N is 1 by 3 in the numerator. A is 1, and it is equal to 1 by 3 into 1 power 1 by 3 minus 1. And similarly in the denominator, it is n is 1 by 6, a is 1, and it's equal to 1 by 6 into 1 to the power 1 by 6 minus 1. And you can simplify further, that is 1 to the power anything is 1, and it's 1 by 3 divided by 1 by 6. and that's equal to 6 by 3, which is equal to 2, and this is the limit of this function. Now you take this question, limit extending to 1 ax square plus bx plus c divided by cx square plus bx plus c, where a plus b plus c is not equal to 0. And it is given that a plus b plus c is not equal to 0. You put x equal to 1, what happens? You just here a plus b plus c divided by c plus b plus a. And as it is not equal to 0, it is not in the form 0 by 0, which is not indeterminate form, and that itself the limit of the function. And a plus b plus c and a plus b plus c cancels, and what will remain? 1, and which is the limit of this problem. And take one more question, limit extending to minus 2 1 by x plus 1 by 2 divided by x plus 2. Here if you put x equal to minus 2, it will become minus 1 by 2 plus 1 by 2 divided by minus 2 plus 2. And minus 1 by 2 plus 1 by 2 is 0 divided by 0. It is of the form 0 divided by 0, which is an indeterminate form. And now to find the limit of the function, you take LCM for the numerator. 2x is the LCM, and numerator is 2 plus x divided by 2x divided by x plus 2. And now 2 plus x and x plus 2 gets cancelled, and what will remain? Limit extending to minus 2 1 by 2x. Now you put x equal to minus 2, you will have 1 by 2 into minus 2, that's equal to minus 1 by 4. The limit of this problem is minus 1 by 4. And see this question, limit extends to 0 sin ax divided by bx. If you put x equal to 0, you will get 0 by 0, and you have to apply the standard formula, that is limit extending to 0 sin x by x equal to 1. And to apply the formula, first let us take 1 by b common, because it is a constant, and you know that limit extending to a lambda into f of x equal to lambda times limit extending to a f of x, and here 1 by b can be taken outside the limit because it is constant, and it is 1 by b into limit extending to 0 sin ax by x. Just I have taken 1 by b outside, and it is sin ax. You know that limit extending to 0 sin x by x is equal to 1. Now I'll just multiply and divide by a. What happens? You just here 1 by b into limit extending to 0, a is multiplied and divided. Now a is constant again in the numerator. You can take it outside the limit in the next step, and it will become like this. That's equal to a by b into limit extends to 0 sin ax by ax. Now it is possible to reduce to the standard form very easily just by substituting, and put y is equal to ax. As x tends to 0, y tends to 0, and that's why the limit will reduce like this. A by b is as it is, limit y tends to 0 sin y divided by y, because ax is y, here this is y and this is y. Instead of x tending to 0, you can replace it by y tends to 0, and this is of the form limit x tends to 0 sin x by x, and that is equal to a by b into 1, and that's equal to a by b. And you remember this formula, limit extending to 0 sin ax by x is equal to a. It is better you memorize this result. Whenever the problem comes, you can apply this result directly, and limit extending to 0 sin ax by x is equal to a. And you should remember this formula, and if the problem comes, and you can directly apply this result. With this, I conclude this session, and I'll continue with the other problems in the next video. Thank you.